Hello, 30-2s. Here is the second lesson in rational functions. Today, what we're going to talk about is equivalence and something known as a non-permissible value. Okay, let's go take a peek at this. Before we start thinking about grade 12, though, let's go and think a little bit more about what we know about fractions from when we were little kids. Really, friends, a rational expression, it's just a fraction, and it's going to follow the exact same rules of adding, subtracting, multiplying, and dividing that we had when we were in elementary school. The only difference will be now is that we're going to have polynomials in our numerator and our denominator. But before we look at those, let's just go back and remember some basics. If I consider the fraction 4 over 8 and 12 over 24, what I would want to say about these things is I'd want to say that they're equivalent. How do I know they're equivalent? Well, I know they're both equal to a half, or 0.5. So what makes them equivalent is that they have the same value. Okay, how did I figure that out so quickly? Well, what I want you to think is comparing to 1/2, I could multiply both top and bottom by the same amount. And when I say top and bottom, I mean numerator and denominator. And that gives me 4 over 8. The thing I want to stress here, what makes these equivalent, is that they have the same value. When we multiply numerator and denominator by the same amount, we're not changing the value, we're simply changing how it looks. Because multiplying numerator and denominator by 4 over 4, well, 4 divided by 4 is 1. So we're not changing the value, we're simply changing how the fraction looks. Well, let's go ahead and look at something in grade 12 now. A rational expression, 4x squared plus 8x divided by 4x. It says, let's find an equivalent rational expression. Well, what we could do is take our given expression and multiply it by any number we want. I'll choose 6 over 6, which is really just 1. And this will give me a rational expression that is equivalent to the original. But the problem here is there's an infinite amount of things that we could have multiplied by. That's going to make it problematic for the teacher. Teacher doesn't want to mark an infinite amount of things. So the method we're going to follow to find equivalent fractions is this. We're going to factor. So this is why we practiced factoring the other day. So here's what we're going to do. We're going to factor, we'll treat the numerator and denominator as two separate things. What can I factor out of the numerator? Well, out of the numerator, there's a greatest common factor of 4x. Can't factor anything out of the denominator. And now 4x divided by 4x is 1. So those can divide. And what am I left with? X plus 2. That is equivalent to the expression that we began with. So this is the process that we will go through when we're doing this unit to find equivalent fractions, factoring, then dividing. Okay, let's take a look at a few more here. So determine if the following are equivalent. So what I'm going to say here is I'm going to go, okay, what if I did this? I look at the 9 and the negative 18. I said, okay, if I wanted to go from here to here, I would have multiplied by negative 2. Well, again, what I do to numerator, I do to denominator. Was the denominator multiplied by negative 2? Well, 3x times negative 2 is negative 6x, and negative 1 times negative 2 is 2. So the answer is yes, these are equivalent. On the next one, well, I'm going to maybe go this way again, and looking at that, well, I can see the 2 and the 1, and the negative 2x and the x. I'm going to say it was divided by negative 2. Right? 2 divided by negative 2 is negative 1, and negative 2x divided by negative 2 is positive 1. Well, what about the bottom? Well, the bottom was simply just divided by 2. So are these things equivalent? No, these are not. equivalent. There it is. All right. So that's a pretty easy question. Now, the last thing we need to think about when we're dealing with fractions is the number we can never divide by. We can never divide by 0. This is going to be called our non-permissible value. We cannot divide by 0. Or values. Sometimes there'll be more than one. NPV for short. We must find this on every single question. So this is crucial to the rest of this unit. So number 3 here says state the non-permissible values for each of the following. Okay, I only look at the denominator. I don't care if the numerator is 0. I only care if the denominator is 0. So what I do is I make a little mini equation. 7x can't equal 0. Solve for x. X can't equal 0. There it is. That is your NPV. That is the only number that we can sub in for x in the denominator that would make it equal to 0. Now, a common misconception is to think that it's always going to be x can't be 0. That's not true. Let's look at the next one. I say to myself, x minus 7 can't equal 0. Add 7 to both sides. There we go. X can't be 7. X could be 0 there, right? That would be 0 minus 7, which is negative 7. That's allowed. I'm allowed to have a denominator that's negative 7. I'm not allowed to have a final denominator that is 0. All right, let's try another one. 3x minus 1. So all I say is I make a little mini equation and isolate for x. Add 1, divide by 3. There it is. That's it. You're just making a little mini equation every time. Okay, let's try a couple more. We're almost done. Again, d 3x squared. Well, what I want you to start to recognize here is when there's an x by itself as a monomial, guess what? It's always going to be x can't equal 0. So when there's a monomial of an x, it's going to be x can't equal 0. Now on E and F, we're at a really good level for 30-2 here. What we need to do here is what we did earlier. We're going to factor. So again, I make a little mini equation. Greatest common factor is x, and you see why that factoring was so important. We did last lesson. Now what we have is x can't equal 0 or x can't equal 1. There's your non-permissible values, and we'll combine that into one statement. There it is. Next one, factor. That's a difference of squares. Oh, there's why we practiced that so much in the last lesson. And now what do we get? Well, x can't equal positive negative 1. There you go. Okay, this is essential. I can't state that enough. You will do this on every question for the rest of the unit. Now, number 4, what I'm asking you to do on number 4 is to go the other way around. It says, here are your non-permissible values. So all I'm going to do is this. I'm going to work backwards. It says I have a non-permissible value of negative 2. So the factor where that would come from is here. And x equals 0, well, that's just x equals 0. So now I'm going to just simply make an expression. X plus 2. I don't care what goes in the numerator. You can put whatever you want, but in the denominator, I have to see x plus 2. So this is working backwards. We're almost reverse engineering the question. Let's try it again. This one says we have non-permissible values of 7.5. So I make the factor where those would come from. On this next one here, I need to multiply both sides by 2, subtract 1. So guess what? Our expression will be this. And the order of them doesn't matter. Again, friends, I don't care what's in the numerator. Hashtag that numerator. Now, one thing I don't want to see is this. This is not your factor. Okay? We're never going to write a factor with fractions like this. So your factor always has to be what's known as an integral factor. It has to have integers, no fractions. That's it, friends. There is the second lesson in rational expressions. This is of extreme importance for the rest of the unit. See you next time.